Welcome and welcome back to our IFM live session. This is the second part and we are broadcasting again live from our headquarters in Essen. You may ask any of my colleagues what a good application solution should look like. The answer is always the same. The more orange, the better. Mostly. Not so in case of food industry. So we are talking about today about food industry, and there you will mostly see products which are not colored in orange, but in shiny silver stainless steel. But it's okay because all the products have other characteristics they can convince with, like high accuracy, high robustness, high reliability. Hi Christiane.
Hello.
Hi Tobias.
Hello.
Hello.
Welcome. Thank you for joining me today. We're talking about now not about sensors, so we don't get into the silver shiny world. But yeah, we're talking about products that are as important as the sensors itself. We're talking about cables and I-Link masters. So Christiane, you're the product manager of cables, which are mostly overseen, I think, which is a little bit unfair.
Yeah, that's also my impression. Yeah.
Yeah, but yeah, it's important so the sensors can deliver the data into the PLC or into the IT level. Yeah. So what is the importance, especially in the food industry, to secure a reliable data flow?
So at first it's about the materials, that you have the materials certified again according the Ecolab certification. Then you have the stainless steel, as you already said, the stainless steel nuts. And most important, we have our own Ecolink technology that we have in all our own cables, where you can install the cables within a few minutes and without a tool. And it's a very secured application in the end. Yeah. Talking about the cables, all the cables, we are delivering the cables for every situation, so beginning from the sensor to the boxes up to the cloud, so that we can deliver all the information from the bottom up to the cloud. Yeah. So that's the most important thing.
Okay, this is the step now. Yeah. But I guess you improve your product.
Yes, yeah. We are improving. Yes, because the application are improving. The applications are improving, and also we are working to have our next bigger cable, the L-coded cable. Okay. It's for applications that are used for the daisy chain cabling. And we are working now to get, with these cables, the power to our modules.
Okay, yeah, perfect. Then we come to the modules and masters. Tobias, the masters and modules also have to withstand the harsh circumstances in the food industry. How do you get them fit for that?
Yeah, exactly. So, as you said, the masters, the boxes, I/O boxes, are also prepared for the food and beverage markets. That's totally correct. And we are using the same technology as we heard from Christiane, the Ecolink technology from the cables we used also inside our boxes. So the connectors are stainless steel, we have special seals, and also it's IP69K. It's really made for this environment, let's say. Yeah, exactly.
Okay.
So when we have a look here to this fairboard, for example, then we have here an I/O block. This is the I/O-Link master here, and the I/O-Link master is directly in between the sensor. That is an I/O-Link sensor, for example, and here is the Ethernet cable that's connected to the PLC. Yeah, and as you see, if something goes wrong in the application, when it's not waterproofed, then we destroy the communication, let's say, and in most of the cases the customer has to stop the machine and the machine cannot produce anymore. And that is, let's say, the worst case. Yeah, exactly.
So it needs a perfect play together between cables and masters.
Exactly. And additionally, it's also very important for our customers that they offer the whole range. So we can see here the whole fair board, and everything is, let's say, gray, and it looks great. It's a perfect design, but we have different products here, and that is also very important for our customers, that they can get everything from the IFM. So not only the IO-Link masters, we have here power cables, for example. We have Ethernet cables for this application. We have sensor cable, of course. Additionally, here we have an passive power distributor for the 24 voltage, also in the same housing.
Okay.
And then here it looks similar. It is an Ethernet switch, so you can say it's an Ethernet distributor.
Yeah.
So an Ethernet switch in the field.
Yeah. So you don't need to get all the cables into a cabinet.
Exactly.
Yeah.
So it's not necessary. So all the wiring you can do in the machine.
Yeah.
In the food and beverage application, and that's great. Let's say.
Yeah.
We offer the whole package.
Perfect. As you said, Ethernet, and we talked about a little bit, or we will talk about digitalization this afternoon.
Yeah.
Let's come back a little bit to the data security. So when I say I'm not sure if I like to get my both networks connected, the machine network and the IT level.
Yep.
Do we have a solution for that?
Yes, we have also a solution for that. So security, IT security is always a topic at the customer, because with the IO-Link masters we are able to communicate with the sensors. So we have some digital communication to the sensor, and we are able to get diagnostic data and more information from the sensor. And this data, this information are also very important for the, let's say, the IT world, for some databases, not only for the PLC. And we offer this IO-Link master also in a data line version. And then you have here on this place here, you have an additional Ethernet port, an IoT port, where you can send data to the IT world. And of course, the additional Ethernet port is here for the PLC board. Yeah. So it's separated, and you're not able to destroy the field bus communication over the IoT port. Okay. So that's a little bit secure, but when we have an application and we would like to send information into the cloud systems, let's say, so it's not an on-premise application. When we would like to send it to the cloud system, then it's better to use an edge gateway in between the IoT port and the edge gateway, and then you can bring it to the cloud systems, let's say. Okay, perfect. Christiane, Tobias, thank you for being here. Yeah, you're welcome.
Thank you for having us.
And we will continue with our next topic. Thank you for your time, and great success with your cables and masters.
Thank you.
Thank you.
See you next time. Bye.
See you. Bye.
Bye.
Bye. As we have already seen here, the TCC sensor on the fair board, temperature is a very important value in the food applications. And Sascha, we are talking now about the temperature sensor Tcc, which helps customers to know more about the accuracy of temperature sensor between calibration points.
Yes. Correct.
So can you tell me how does it work and what is the benefit of it?
Yes, for sure. Thanks for being here, and welcome also from my side. The temperature sensor TCC is a standard temperature sensors, but with a designated use. We've looked for special secureness of processes where temperature is crucial to be precise. And that's where the TCC starts, the idea, and the follow-up product as the TCC is from the former TAD. We have spent a lot of knowledge in. We have some nice programming. We have a dual element at the bottom, which is diversified, so extra secured. And the idea was to give the customer an out-of-the-box temperature sensor, which brings extra secureness for specific temperature points where nothing shall go wrong with the temperature. And that's the TCC.
So does it mean I don't have to calibrate anymore, or?
Yes and no, I would say.
Okay.
That's the tricky part. From the technology itself, I would say yes, because we have here a verification of the measurement or the value of the measurement 24/7.
Okay.
But you told something that this could be some sort of a bridge between the calibration processes. Because we need to think of the customer who are using that kind of product is mainly used on so-called critical control points. And the critical control points are like there shall be nothing going wrong, like pasteurization of milk, where it's crucial to kill the bacteria.
Yeah.
So there are a lot of parties involved, like quality management, like maintenance and so on. And to say to them, you can leave your calibrations would be a little bit too offend.
Yeah.
I would say let it naturally grow. Use the TCC, you have a lot of advantages. You have one sensor with all the programming inside, so you don't have to care about two sensors installing, programming. And TCC at that point builds an extra safety net and gives a proactive notification because calibration is every time just a snapshot of the actual situation. And here we give an extra safety net about that. So the natural way would be that customers say after 1 year, 2 year, okay, it does the job. I can adjust the calibration intervals, for example.
So it means if I know, you said he's checking itself 24/7, so I know exactly when the sensor is drifting. He tells us when he's drifting, and so I can react much earlier and don't have such a huge loss of products.
Correct. So it immediately indicates when the measurement is incorrect or when the deviation is too high from what you have placed in the parameters. And it gives an indication via the LED dome.
Yeah.
It turns blue. And of course, the switching output in the analog world is then switched, or via I/O link, you got the messages over I/O link on that point.
Yeah.
Yeah.
Perfect. Yeah, Sascha, I think that was a good short overview about the TCC. I think if there are more questions now or later on, the attendants can contact you or just write the questions down in the chat.
Yeah, definitely.
Answer them.
I would stay in the chat afterwards, so
Perfect.
feel free. Otherwise, of course, feel free to contact our sales channel. And
okay. There's a question. I've had a calibration engineer ask me how he can simulate the output at the probe end for calibrations on IO-Link.
Yes, that's a very good question, and therefore the TCC has a simulation mode installed. So you can go into the settings via LR device and enable the simulation mode, so you can simulate a specific temperature, but you can also simulate specific statuses like a drift warning, so the blue indication, or even we have a red indication when something really is a failure on the sensor. So it's like the onboard diagnostic on your car. It tells you when something goes wrong. And here for the to check if the value from the sensor goes to the PLC and is displayed there correct, you can enter 20 degrees, start the simulation, and check what kind of value comes into the SPS PLC.
Yeah. Perfect. Okay. So, Sascha, thank you very much.
Thank you also, and have a good day.
Yeah, thank you too.
Thanks.
And we continue with our next topic, which is a completely new product and a completely new technology for IFM. Marco Schreiber is with me now. Hi, Marco. Thank you for being here.
Thank you for inviting me again.
Yeah, we're talking about, I said it, about a new sensor not only, but it's a completely new technology. It's radar. We're using radar now for level measurement. And there are so many features in this sensor. We could start everywhere. I think it will be best to explain why radar is such a good technology for level measurement.
Yeah.
So maybe we can start with that, because it's not a typical or known radar sensor. It's the 80 gigahertz technology.
Exactly.
Yeah.
And that's how it is. So for IFM, this is a new technology, especially for level measurement. And we now have here our new LW2720, very proud of, directly from stock. Yeah, directly from the first packages, and we are happy to present it. And as you said, this comes with radar technology, 80 gigahertz. So 80 gigahertz is very well known so far as a level measurement technique, and it has its advantages compared to other frequencies in radar technology. The good thing with 80 gigahertz is that with this high frequency, you can set up a sensor with a very narrow beam angle and at the same time having a very small process connection.
Okay.
Yeah? So that means with other lower frequencies you would have bigger process connections to get the same narrowness of the beam angle. And this has different advantages in the process industry.
Yeah, that's the next question. So what are the advantages of this narrow angle? What are the tanks maybe that are perfect to use this radar sensor?
Yeah, so level measurement is actually not that easy as it typically seems. So we typically have harsh environment, different and difficult applications, and that starts, for example, in food industries with internal constructions within tanks. So it happens very often that products need to be stirred, and to stir the product within the tank, there are agitators installed. And as you can imagine, when you have a technology that has contact to the medium, like our guided wave radar, or even non-flush pressure sensors, this could be a disturbance for the measurement, or not even possible. Now with the non-contact radar solution, which is installed on top of the tank in a process connection, we don't have food contact, and we, with this narrow beam angle, that's what we were talking about, we have the possibility to ignore all those constructions, because the beam angle is so narrow we don't even see that, even with very tall and high tanks.
Yeah, it doesn't hit the agitator.
Exactly, it is not disturbed by the moving agitator, and clearly an advantage compared to other technologies in this case.
Yeah. How accurate and how fast is the measurement with the radar sensor?
Yeah, it's very accurate and very fast.
Okay.
So we can go to tank heights up to 10 meters, and over the whole range of this measurement, we can achieve an accuracy of plus minus 2 millimeters.
Okay.
And this is very important. So everyone thinks who needs to measure the level with this accuracy, but it is really needed, because as you can imagine, when you have very big tanks with a very huge diameter, even a few millimeters add up to a lot of volume, several hundred liters at the end of the day. And depending on how valuable the product is, it is a very critical point to measure the level correctly when it comes to for example, for insurances. So when you have to prove how much of your medium, of your liquid, maybe wine, is in your tank, and it's a very valuable wine, then every liter counts.
Yeah, sure. When we come back to the topic of speed, as we can see, the sensor is just only one connection, and you brought an adapter with it. So you mentioned in our talks before, the speed is not only inside the sensor, the speed begins also in the installation and in the parameterization.
Exactly. Yeah. So this is like I said, I just took it out of the package, and what our customer needs to do at the end of the day, need to take it out of the package and install it. set one parameter, namely the tank height, and then it's ready to go. Yeah. So it's a very easy to use, compact product. That's what makes it so attractive, and customer can really handle it by themselves. There's no difficult parameterization involved. There's no blending out or ignoring or ignorance of obstacles, anything. Yeah, it's all implemented in this very very intelligent algorithm, which has the capability to follow the level surface and also proves if what it is measuring is correct or not. And this comes, of course, in addition with our modular approach. Like with many other sensors, we have hygienic adapters, which is especially interesting, for example, for retrofits. So when there is an existing tank with an existing connection, you can simply choose from our adapters which adapter fits into this process and easily retrofit our sensor into existing process connections.
Yeah. Perfect. And as I know you are the product manager for Moneo Blue, correct me if I'm wrong, the sensor can also be parameterized by this app.
Exactly. So we have no Bluetooth integrated, but we have a little adapter, our EIO 330.
Perfect.
And by using this, you can connect to our Moneo Blue app, and this allows also for a very easy parameterization of the sensor. You have a graphical user interface, especially designed for the sensor, which makes it very easy to set switching points, analog input, output, and so on.
Perfect. Marco, thank you for being here. Thank you for presenting this new technology, this new sensor. And
thank you.
Yeah, we have a question. Can this radar sensor be used on wastewater plants?
In principle, yes. Especially with all water-based application, it works perfectly. But what I have to say, this is a hygienic design. So all of this sensor is designed for a hygienic market. It comes with all hygienic approvals, like 3A, EHEDG approvals, with USP Class 6 approvals. That means not only for food and beverages, also for pharma suitable. Yeah, so that's what it's designed for, and that's what we are actually looking for.
Okay, perfect. All right. Okay, and again, the question, what is the maximum height of measuring?
Yeah, the maximum height is, like I said, from the technical data sheet, we say 10 meters. It can also go a little bit higher, but this is where we, for the media, we advise, and for the accuracy, we state, this is what we advise, 10 meters.
Okay, perfect.
Yeah. Great.
All right.
Thank you.
Marco, thank you. Bye. So now, from one level measurement technology to another, Stefan Heide will now join our IFM Live Talk. Stefan, come in. Yeah. So, Stefan, hi. Nice to meet you. Yeah, we already talked about radar technology. Now it comes to ultrasonic technology, and yeah, it's not a new technology, but maybe we can talk also about the advantages of this technology first.
Sure, Philip. So ultrasonic sensors are very common in industry applications like automotive, different industries. Ultrasonic sensors are well known. The principle is based on the time of flight principle, so the transducer who's in the front has a ceramic cell and is transmitting sound into the air, and from the reflection the sound's coming back, and based on this time I get information about the distance. Based on this technology, we have a lot of advantages in this product family. So we can detect transparent objects like plastic trays, transparent liquids in bigger tanks on a height of up to 8 meters.
Okay.
Furthermore, we can detect objects with an irregular surface. But even levels with an irregular shape, you can detect very successful on long ranges with ultrasonic sensors. And very often ultrasonic sensors can be used when photoelectric sensors reach their limits.
Yeah.
Then you can use the ultrasonic sensor for industrial applications. Has a normal IP67 rating, and we made a lot of experiences over the last years, and that's the current status.
Yeah, perfect. And as we're here for the food industry and we're talking about a lot of stainless steel, you've developed and launched a new product, which is, or a product range, which is the UIT 300 product group. This is, I think, very special, and maybe we can show it first. You brought an example with you.
Exactly, and here it is. That's the all-new full metal ultrasonic sensor, also in an M30 housing, and maybe now you can see both sensors side by side, and you see some differences. Yeah. And let me just explain why they are looking different, and why I also have now a full metal sensor, like the previous colleagues explained it. So IFM gained a lot of experiences in different applications, and we solved a lot of applications. But over the last years, I saw more and more applications where I said, I need a more robust sensor which withstands different chemicals, cleaning supplies, oil vapors, gases, etc. So the idea was to have something more capsuled. Yeah. But it's not so easy because, like I said, normally ultrasonic sensors need to send sound into the contact medium air. Yeah. And there's something which needs to vibrate. If I put it into a stainless steel housing, nothing goes out. Yeah. So this was the biggest difficulty we had in the development of the new full metal ultrasonic sensor UIT3. At least we were able to generate a full metal ultrasonic sensor from the connector up to the front, which still reach ranges of 2.5 meters. Okay. And we have now also an IP68K rating, which makes it also suitable for food and beverage industry. IFM is very successful in the food and beverage industry, and I think with this product we have also the chance to solve more and more applications in this sector. And now we have the first full metal ultrasonic sensor also with IO-Link for sure. Like Marco said, all our products, they have IO-Link. You can transfer the distance information in millimeters to your PLC. And also, it's a great new product that we can launch today. Yeah, and it's not only interesting for the food industry, I think. As you said, ultrasonic sensors are in nearly every industry. Of course. The food and beverage, why is the food and beverage industry maybe so interesting for the full metal ultrasonic sensor is customers are cleaning the machines and also the integrated sensors with high pressure. Yeah. They're using cleaning supplies, for example, from company Ecolab. Therefore, we also have the Ecolab certificate, so we made the test, so it withstands all the cleaning supplies. Okay. In some applications, for example, in tooling machines, if you want to detect levels in close to tooling machines, you have oil vapor in the air. Even the oil is very aggressive and is able to attack normally the front part of the ultrasonic sensors, and the oil can diffuse into the sensor and destroy the sensor. So the customer maybe needs to exchange the sensor every 6-12 months. Okay. And with this sensor, you install the sensor and you forget the sensor. Another interesting application is, for example, the production of hand gloves. Okay. Especially in the current time, it's very present. Hand gloves are made of latex, and you have preforms which are going through a bath where this latex is inside. Yeah. And to check the right level, it's very critical for the process, because if the level is too low, you can imagine the glove becomes very short. Yeah. And but on the other hand, the latex has also some ingredients which are also very aggressive for normal sensors. And with the full metal sensor, it's very easily to solve. And there are so many other applications. For example, plastic granulate. You think, okay, plastic granulate is a normal medium material. If a customer wants to detect continuously this level of plastic granulate in a tank, you need to be aware that some plastic granulates have also some gases which are coming out of the plastic and can also destroy the sensor. And therefore, we also have this more robust solution. Perfect. Stefan, thank you for this short overview. Thank you for being here.
And if there are no questions left, we will now sum up the whole product in a short film.
I think there's one question.
That's a question. Yeah, I'm sorry. So, what kind of liquid is the worst for this device?
Yeah.
It's a special question.
This is a very special question. The worst is, so in general you can say all medium which are attacking full metal, stainless steel. These medium are also not common for these sensors.
Yeah. Okay.
And but I saw many customers they have baths made of stainless steel. For these customers, it's perfect. So of course, in the semicon industry, for example, they need to be careful. For example, with stainless steel, for sure. Therefore, IFM has other solutions. But in general, a lot of applications you can solve. Yeah.
All right.
Good.
Perfect. So I think now it's time for the video. No, another question. Can the sensor be configured with the iPhone app? I think it's the Moneo Blue app.
It's a very good question. Sorry that I forgot this important point. Of course, the Moneo Blue app from IFM, which was also shown in the previous video from Marco, of course, is also suitable with the full metal ultrasonic sensor. So you can connect it, parameterize the thresholds. Also, for example, for the analog outputs, you can do it with the Moneo app perfectly. Perfect. And of course, it works.
All right. So now, third try. We can see the video now. We're back again, and with me now Robin Skade. Robin, thank you for being here again.
Hey Philip,
you're doing
glad
fine?
Glad to be back.
Yeah. So, as we can imagine, in food industry processes, nothing works without pipes, and these pipes has to be cleaned by time to ensure there's no residues left in these pipes and get into the new products. So you can clean the pipes with maybe a huge amount of water, or you can use a SIP process. And I think when it comes to the SIP process, you need to be sure that there are no chemicals left in the pipes. Yeah. And this is where your conductivity sensors comes into play.
Exactly.
We're talking about now about the LDL200 family. So you have some variations about of this LDL200 sensors. So can you just explain at the beginning what is the task? What is the task of these sensors?
Yeah, sure, no problem. So as you said, if you're having a CIP cycle or you're gonna clean your food process anyhow, then you're gonna have those reoccurring steps of water being flushed through, having acids, having bases running through the system, and the most critical part is the final rinse process, where you put water through your system until there's no chemicals left in there, and also the process steps in between, because there are two options. Either you're gonna do it by conditions, or by time. So one, do it that you have, like, let's say half an hour of water, 20 minutes some kind of acid, and you can imagine that there's a lot of safety factors in there, that in the end you can really say it is clean, and I can start my new product again. But if you're going to do it on a condition-based measurement, then you can use our LDL family for that, because with each step you can see, all right, now water with a conductivity level used, like let's say around 100 microsiemens or 200 microsiemens, what you're putting into your system. And then on the other side of the system, you're going to have another LDL to see, all right, my system is now at like 400, so you know there's residue left in there, until you have one measurement on both sides, so the same number. Then you can start the next process step. Okay. And obviously you can save a lot of water, a lot of chemicals with that. And this is what the LDL mainly is used for, so to optimize this whole process.
So you brought some products with you. We can see they are a little bit same, but also a little bit different for each. What gets into the eye first? It's a very compact sensor. It's no display, no nothing. Just this small sensor, I think. This is special for conductivity sensors, I think.
Right. What there's out in the market is like a lot of big voluminous sensors. It's not really about being the compact sensor. So you have like the evaluation unit within your sensor. This is like quite common, especially for the inductive measuring principle, like the LDL2 series, one example. But still, most of them are really, really big. So if you take a look at it, that you have like a handful of sensor, let's say, and if you compare it with other products in the market, you have like 3 times the size, even 4 to 5 times the size. And then we wanted to, with the whole family, to take a step back and try to minimize it as much as possible, because you have to think about it that with increasing variety of products, you will have to have smaller systems, and also OEMs really do like to have compact systems which they can send to the customer or build on the customer side, and then what you don't have is size on everywhere, or you don't have enough room to implement all the sensors. You have to construct your pipes around different sensors. And with the LDL2s, we are really on the compact side to fit into nearly all systems that are out there.
Okay, so the newest one is the LDL220, which I think is this one.
Exactly.
But let's come back to the other ones. So what are the differences between each sensor?
Sure. On the one side, I can just show it right here. So on this side, here's an LDL 100. This is a conductive measuring sensor, which is mainly used for phase separation, so you know what's happening in what pipe, not really for exact measurement.
Okay.
Then on the other hand, you have the LDL 200, or in the middle, the LDL 201. Those are our inductive measuring principal sensors, and those are really the one for measuring. But now we have to think about, right, it's the same sensor, but on the one hand it's the same, but on the other hand it's not. So what really is the difference is the process connection or the insertion depth. What you can see on the right side here, that the sensor is installed into a Varon line pot. So when you have, like, for an example, a DN40 pipe, so having, or even up to 2 inches with like DN50, DN60, and then having to think about it that you have like the tip of the sensor, because it's a 1-inch process connection, you will fill up the whole pipe and have a huge pressure loss. That's why the 200 is mainly used with barrel line, or even with if you have bigger pipes with welding adapters. So you don't have the pressure loss in the end. But on the other hand, when using clamp, because the measuring pipe you have on the bottom of those sensors has to be flushed with the medium completely. So you're measuring the medium and not like some mixture of air and medium, because air obviously is not conductive. So this is something to keep in mind. So this long insertion depth then is, for example, for clamp adapters or SMS, milk pipes and so on. But coming back to the new one, so we're gonna can take a step back. Is the huge difference obviously is the size, comparing to the LDA 200 for 201 for an example. So it's really small, and as I said, like being smaller DN50 for an example, you have a huge pressure loss. And even when you go below that, so having high variety, smaller systems, but those small systems need to be cleaned anyway. Then you're going with the 220, and this is something completely new to the market, because there's no really solution to go into smaller pipes, even smaller DN40. So just for an example, so I have here a T-piece for DN25, and if you just go in and screw that in, so you can see now it's got to find the right camera. Here you still have a lot of space left in there, and this is something customers couldn't solve or cannot solve without having such a size. So we really wanted to have a bigger variety here, expanding the portfolio that is out there and try to fit into as many applications as possible. Doesn't matter the size or the process connection.
Perfect. Robin, thank you very much for being here the second time and explaining the LEL 200s. You did it well. No questions left. So you are reachable in the chat if there are questions later. So perfect. Thank you very much. Thanks for being here. And thank you for watching. Thank you for your interest. This was the second IFM Live Talk. I would be delighted if you will be with us this afternoon on 15 o'clock, 3 p.m. We will talk about the smart and easy way of digitalization. And tomorrow at 11 a.m., not p.m., a.m. CET, we will talk about the solutions for intralogistics. See you then, take care, stay healthy, and bye.